The Abbey Gardens sundial, Bury St Edmunds, an item of significant horological, scientific and cultural interest. The Abbey Gardens sundial and fountain was donated to the city of Bury St Edmunds in 1870 by the 3rd Marquis of Bristol. It was originally installed outside the Nutshell pub, Britain's smallest pub, in the Traverse. However, it impeded wider vehicles and was moved to the Abbey grounds in 1939, where it now serves as a decorative planter. It is Grade 2 listed and thus under the aegis of St Edmundsbury Borough Council. Attempts are being made by the Friends of the Abbey Gardens to raise sufficient funds to suitably restore or conserve the dial. The dial is of significant horological, scientific and cultural interest to both Bury St Edmunds and a wider audience. This presentation seeks to explain why it is of more interest than would be apparent to the casual observer. The year warns you, and the hour that snatches the kindly day away warns you, don't hope for undying things. The sundial itself on the south face and the motto on the east face are nice, but relatively ordinary by Victorian standards. It is the strange inscription on the west face that is of interest. Time and the weather have made it difficult to decipher the inscription, suggesting that some restoration or conservation is required. The curve on the Abbey Gardens dial was first described by Dr. John Davis, who lives in Floaton in Suffolk, in 2005. He recognised that the red curve relates to the equation of time, which is the difference in minutes between solar time and local mean time. Mean time is told by the uniform movement of the stars around the equator. Solar time is told by the sun, which moves non-uniformly around the ecliptic at 23 degrees to the equator. Until the Enlightenment, the world used solar time, told by sundials. But in order to find longitude, navigators need to use local mean time. From the 17th to 19th century, driven by the needs of navigators, commerce, science, and the increasing number of clocks, local mean time gradually took over from solar time. However, one needs an astronomer to track the stars in order to measure mean time. In the absence of an astronomer and the need to set an ever-increasing number of clocks, many sundials were supplemented by a graph or table of the equation of time to allow solar time to be corrected to local mean time. With no time signals, clocks could now be set to mean time. It is the first sundial in the world to acknowledge a national mean time, GMT. This is the normal Cartesian XY graph showing the equation of time over 1 year. One can see that the difference between solar and mean time varies between plus 15 and minus 16 minutes in a meandering fashion throughout the year. After Dr. Davis's description, Professor Frederick W. Sawyer III, a US academic and mathematician, recognized that the Bury St Edmunds curve was an intrinsic curve based on the work of William Whewell, the 19th century professor and master of Trinity, Cambridge. A traditional Cartesian XY curve has equal time steps represented by equal increments along the x-axis. This type of intrinsic curve has equal time steps represented by equal increments along the drawn curve. Drawing a normal Cartesian curve. Go along by a fixed time, e.g. a day, and up by the change in the equation of time to get the point for the next day, and then repeat. Drawing an intrinsic curve. Go outwards by a fixed time, e.g. the day, that's the circle, and up by the change in the equation of time to get for the next point for the next day, and then repeat. But note that there are two options to choose from to find the next point. The possibility to go in the direction of option A or option B means that the intrinsic curve may be folded on itself. This allows a large amount of data to be presented as a graph in a compact but easy form to read. This shows the equation of time plotted intrinsically without folding. Now we will fold it and fold it and fold it again. Now we will shift the origin from the 1st of January to the 1st of December and fold and turn upside down. Clear, compact and stylish. The dial's equation of time is rare, aesthetically pleasing and of considerable mathematical interest. The Abbey dial has a mathematically esoteric representation of the astronomically and horologically interesting equation of time. In researching who was involved and how it came about, an extraordinary web of interconnections became apparent between friends, family connections, Bury St Edmunds, Cambridge, astronomy and design. William Whewell, Victorian polymath, mathematician, scientist, priest, philosopher, theologian and historian of science, Master of Trinity, Professor of Mineralogy, Professor of Philosophy, Vice-Chancellor of Cambridge, coined the term scientist, physics equals natural philosophy, ion, dielectric, anode and cathode, produced 2 papers on intrinsic equations in the 1840s. Thus was the grandfather of the Abbey Gardens dial curve, connected to Bury St Edmund through his second wife, Lady Evelina Affleck. George Biddle Airy, brought up by his uncle in Suffolk, Sizer of Cambridge, Senior Wrangler in Maths at Trinity, Fellow of Trinity, Professor of Maths, Astronomer Royal, where he failed to discover Neptune, established the Greenwich Prime Meridian. His father and his adored sister lived in Bury St Edmunds, and he walked from Cambridge to Bury and back many times, 27 miles, and helped to raise interest in the Bury Athenaeum Observatory. Best friends and academic colleagues. Frederick William Hervey, 2nd Marquess of Bristol, undergraduate of Trinity, supervised by George Biddle Airy in 1923, lived in Ickworth, 3 miles from Bury, MP for Bury, Privy Councillor, Fellow of the Society of Antiquities. Supervisor and student. The Right Reverend Dr. Lord Arthur Harvey, Trinity First Class in Classics, Rector of Ickworth, linguist, antiquarian and amateur astronomer, Bishop of Bath and Wells. Fellow astronomers and brothers. Frederick William John Harvey, the 3rd Marquess of Bristol, undergraduate of Trinity, MP for West Suffolk, created the Pompeian Room at Ickworth, Lord Lieutenant and Keeper of the Rolls of Suffolk, donated the Abbey Garden sundial to the town. Family members. Francis Penrose, studied architecture and mathematics at Magdalen College, rode 4 times for Cambridge, architect, archaeologist and astronomer, discovered the entasis of the Parthenon. When surveyor of St. Paul's Cathedral, he had a significant dispute with the dean and chapter, which allegedly caused him to take up astronomy. Had a particular interest in technical and graphical solutions for astronomical problems, and used a theodolite for accurate determination of orientation and time in connection with the fixing of sundials. Architect of the Pompeian room at Ickworth. Designed the Abbey Gardens sundial and was certainly the father of the intrinsic representation of the equation of time on the dial. Fellow of Magdalen, Director of the British School in Athens, and President of RIBA. Client and architect. The dial is associated with some very significant academics and indicates the 19th century intellectual sophistication of Bury St Edmunds.